Can you see my can you see my attachment? Hello? Can you see my PowerPoint?
Yes, doctor.
Good. Okay. So what to do now? This is black color. Go here. Okay. So we continue with analysis of trusses today also. Of trusses. Why it is plural? Because it is a lot of two force member that are joined together. Okay, let me remind you, if you have a structure like that, okay, remind it again. This is point A, this is point B, this is point C, this is point D. Okay, and then you attach that structure to another structure there, something like that. Okay, something like that. All right. So what to do now? If you and then you are attached with this roller, something like this. Okay, that means you have one forces only, and another corner there you have you attach that structure with a pin. Okay, and then you apply a force. You apply force in a different. So say this is point A, this is point B, this is point C, this is point D. So in actual fact, AB is a structure. Okay, AB is a solid structure where we have a hole to join a pin, point A and point B, point C and point D, and then you apply a force. Okay, you apply a force for something like that. Many configuration there. Force P. Okay. The first step for you to analyze the structure is to redraw the free body diagram correctly. Okay, redraw the free body diagram correctly because mark given for you. Okay, a mark given for you when you draw a free body diagram. If you don't draw the free body diagram, so we will reduce your mark for 1 or 2 out of 10 in the final examination. So we are now targeting your final exam because it is so close already. Okay, copy that one and paste. Okay, so the first thing to do is to draw the free body diagram. Okay, insert, draw, erase, medium erase. So the first thing to draw is to draw the free body diagram, overall free body diagram. Okay, so listen to me, don't draw a force with the pin. Okay, don't draw force with the pin. Okay, when you remove the pin or the reaction attachment there, when you detach it, then you have the force. Okay, then you have the what? Then you have the force. Okay. So draw. You have CX, CY, and then what point is here? D, DY. Okay, this is point D. What to do now? You draw a free body diagram. Okay, then you use a summation of moment is equal to 0 any point, summation of force in X equal to 0, summation of force Y equal to 0. Then you will have a dx, okay, cx and cy that equal to you can get the value of the cx and cy. Okay. Then what we call it as a join method is you want to join the analysis at join. Join is A, B, C, D. The first thing to do is you assume all the forces are in tension. Okay, in tension. Okay, all the forces are in tension. Okay, all forces, all structures are in tension. Okay, all the forces are what? Are in tension. Okay, assume that. All the forces are in tension. So, how to illustrate the structure in tension is my pull out. Okay, you have to pull out the structures. So, put it in the different color. So, we assume, so T A B here, tension. T A D here, intention. Okay. T A C here, intention. T C D here, intention. And you have T B D here, also intention. Okay. And to maintain in equilibrium, you should have another force, same force here. T A B, T A D, both must be in the different direction. So T A C, okay, T A C, okay, and then T A C as well. So T C D, T C D, T A D, T B D, and you have a T B D there. Every point, okay, every point there. And then you remove the main structure, the structures, the frame, okay. Remove it. That's it. Remove it. Okay. These are the only things left. Points is a joining. It's a join at every structures A, B, C, and D. And then you do what to do now. Again, you do just a summation of force in X equal to 0, summation of force in Y equal to 0 for all conditions. For every point there. Okay, for every point there. For that point, and also that point. And then you will get, go to, please do analysis at point where you have what? Where you have the unknown is only 2. Find a point or a joint where you have the unknown is 2. In this case, get this one. This is, you have, remind me, this is TAB also. So in that particular case, you do analysis at point B first. After get point B, go to point A. Okay. And then go to the point C. Then you got all the problem. Resolve all the forces. You don't need to do the analysis at point D. But in case we ask you to do, please do the calculation of all joining. And then you have to do all. Okay. I think you are clear with this. You are very clear with this. Okay. Let me give me 1 minute to share with you another some special structure in the trusses. Okay, I remind it again. So desktop, I remind it again. Go to where? Go to statics. I go to Go to analysis of structures. Go to trusses. Structure. This is what we did yesterday. And exercise. File. Save as. Into the desktop. Save. File. Save as. Into the desktop. Save. Okay. Are you with me now? Hello?
Yes, Doctor.
Good, good. Okay. So what to do now is I should go to close this. Go to here. Go back to here. And then I should go to let me save it, okay? File, save the desktop into week 11 lecture 2 into the desktop, okay? Go here. But if you found can you see? Okay, no. Can you see my sharing here? In a PDF analysis of structure.
Yes, Doctor.
Okay, so we discussed it yesterday. Sorry. Okay, there are several cases. There are several what? Sorry, batuk pula. Batuk lah, sedih tak ni Sedih Sad cannot see my student. As a cikgu, I want it to see you again and again. So you make doa for you to come here. Change color for that. Okay. So there are we discussed this. Okay. I'm pretty sure that you understand it. Okay, this, and then there are several structure. Okay, if you have this is a point, it's a joint. You have four structure that attach together. If AE and AC are aligned, and then AB and AD are aligned, okay, force AE and AC is similar. The force AB and AD are similar. Same force. If you have, okay, three force member, which two of them are in the line of action, it means that, okay, AD and AC are aligned, okay, and you have attached that AB to that structure. AB means nothing. It's zero. Force in AB is zero. And force AC and AD are zero. Okay? And we discussed yesterday, if you have two force member, okay, that attach in a line, okay, both of them are in the same force. Okay? If you have two force member, both of them not in the same line even, not in the same line, okay, not in the same line, not in the same line, okay. So AC and AB are equal to zero. So equal to zero. So let me share you this. Let me, okay, look at your book. I want to do this now. I want to do one by one. So make sure you crystal clear about this. We go move to here, and then what to do now is edit and copy. I'm very good already using software now. Okay, paste to here. Make it big for you. Okay, there. And then another one. Where is another? Here also. So edit. Take a snapshot of it. Go to there. Copy. Go to here. Paste. Okay. The question says, where is the zero force member? There. Which one force is zero? We begin with the. Can you open up your microphone now? Tell me this structure. We do this together. Hello? Which one zero?
TV.
TV. So that one begin with this. Okay. So see, that one is attached that one together. So this one is zero. Correct me if I'm wrong. That one is zero force member. Okay. Clear? When that one zero, that one is become, that one align with that one is zero also. Okay. Which one zero? Tell me. That one not zero because you have three forces there. That one not zero there. That one not zero. Okay. So interesting to see at point G. Point G, okay. If you don't have this force P, okay, GD is equal to zero. GD is equal to zero. Since you have force P, you apply force P, okay, GD is not zero, sayang. Ada lagi tak force zero? Tell me. Okay, good. That's only, okay. So that one is zero. Force there is zero. Force inside there is equal to zero. Okay, we move to the next structure. There are a lot of zero force member here. Tell me. To begin with this structure, okay. Begin with this structure. Look at A, B, B, D. And then you attach one structure here, that one is 0. No force there. Which one? When this one will be 0, when which one 0, you look at the attachment AC to CE and then to DB. So look at the point. Look at the point. So that when that one 0, that one also 0. Okay. No force there. That one also 0. That one also 0. That one also 0. Look at the point M. Look at point H. When that one 0, that one also 0. No force there. Mana lagi? Tell me. When that one 0, so look at that. That one 0. Look at the point M. Point M is attached to 3 structures, means. So that one also 0. Okay. When that one 0, look at point K. Look at the point K. Okay, that one also is attached to 3 components. Okay. IK, KM, and KI. So it means that that one also don't carry any force. That one also 0. J to L is 0 or not? J to L is 0 or not? Hello? J to L is 0 or not? Hello? No. No. Because you attach at point L, look at point L. L to E, okay, is another structure. L to M is another structure. But L to J is not 0 because you have a force there. That one is not 0. So I think here is finished. That one is that one also 0. Look at the point. Look at the point. Point here is at normal. Okay. Look at point this. This one is not 0 because you have 4 forces there. Now look at that point. That point is not 0 because you attach 1, 2, 3, 4, 5. 4 of 1, 2, 3, 4, 5. Not a 0 there. Okay. D to G is not 0. Okay, that's it. All right. You have to determine. We used to ask in the examination, please identify the 0 force member in the structures. So
Morning, doctor.
morning, yeah.
I would like to ask for the just now question, the third slide.
Third one, okay.
Why is BD not a 0 force member?
B,
D.
BD because who is asking me?
Yong.
Okay, you are good, Yong, asking me. This is BD, okay. So you the point B is attached to now is A to B, B and C. Okay, unfortunately for this structure, you attach that to another structure B and D and also B to H. Another structure there, BH. If no BH, BD will become 0. Good one. Understand, Yong?
Sir, then why BE consider 0 while BD is not a 0 member? Does
YBD, a good one. Good, good. Saya padam, saya buat YBD is considered as 0. Who is asking me?
yep, no, I'm asking why BE is a 0 member but BD is not a 0 member. Because these two are symmetrical, right?
No, we don't do symmetrical. I will do it again, okay? How to erase this? Erase. Medium erase. How to erase? Yes, it doesn't go with the structure, it's fine. I'll do it again. You look at the point. Sometimes I also miss this to work in the computer in front of me. Okay. Change color, blue. Now we use blue. Okay. Look at the point. That point. Okay. So EI is 0. EJ, sorry, is 0. No force there. Okay, no force there. So you look at that point E. Point E, you have 3 structures. Okay, C, E, H is aligned. You have another structure there. So, okay, you have another structure there. So that one is 0 also. Because what? Because you have 3 structures. That one align with that one. So that one don't carry any force. That one is 0. Different than this. Different than this point where you have here 4 forces: D to A, D to H, and D to G. As I mentioned just now, if you don't have force P, then that one equal to 0. Then that one also to 0. Clear? Okay, good. So file, save. Then second structures, okay. Second method to solve is the famous one, is the simplest in the world. Okay, is the simplest one. We call it as a section. Section method. Section method. Okay. You make wish or make doa for those who are Muslim. Okay. So that we will not ask you on this joint method. We will ask you a section method only. Okay. Okay. Already. Let's say you have a very complicated structure. You will be engineers. Okay. You will be the best engineers. Okay. So you have structure A to B, B to C, C to D, D to H, something like that. So there to there. Okay. One attached to that. That one you have attached that structure into that. Then you have that structure something like this. And then you have that. Then that structure attached to that. Very complicated structure. Okay, like a bridge. Okay, like a bridge, and then that attached to that. Okay. Let's say this is point A, this is point B, this is point C, this is point D, this is point E, this is point F, this is point G, this is point H. So at point okay. So what to do now? You attach that forces at point H you have you have a fixed pin there, and then at point E you what to do now? At point E you have a simple roller there, okay, something like that. Simple roller there. So you apply many forces on the structures. Okay, you apply force at point D. P is equal to 100 Newton and so on and so on. And point here you apply force. Q is equal to 200 Newton. And at point B you have, okay, say, tell me 300 Newton. Okay. So the first thing, okay, we are now concerned about your understanding. You do online and so on. The fundamental physics of the structures of analysis to be engineered. So it should come with the drawing of analysis. It should come with the free body diagram. Okay. I very hate the student when he just draw a force, say Hx and Hy, without removing the structure here. Why you have structure? Because you remove this pin. You remove this pin. That's why you have force. If you don't remove it, it means no force there. If you don't remove it, no force there. Okay? Since you want to do the free body diagram, then you have to okay, Control C. Copy this one and then paste this one. Okay. So now let me to do now is I want to remove this pin. Remove this pin means it come out with it must be replaced with the force. Okay, removing the direction and so on. It must come out. It must be replaced by force. Okay, it must no. I do this one first. Okay, this is point E. When I remove this one, okay, then you have a force. So here is, we call it Hx. Any direction that you like, as what we did yesterday, this is Hy. And this is Ey. So what to do now? You draw the free body diagram. First, this is a erase, medium erase. Be careful here. Be careful here. We may trick you with zero force member inside there. There is a zero force member inside there. Okay, which one now? Tell me which structure is not don't carry any force. Don't tell me which structure. Hello? Or are you talking to chat? BD, Siti Aisyah. It's not BD. It's a which one don't carry any force? It's a GC don't carry any force. Free body diagram. Okay. A section method. When we do section method, you cut it. Section. The maximum you can cut is 3 structure. Okay. The maximum you can cut is how many structure? HV?
Yes, doctor.
How many structure you can cut? Puspa. Kunita, how many structure that we can cut?
3, doctor.
Very good. Okay, 3. The maximum you can cut is 3. The maximum you can cut is 3. You potong terus. So we will ask you in the exam. So the structure below is in equilibrium. Determine the forces in BC. I ask you now, get the force in BC. Okay. Get the force in BC. CH, BC, CH, and HG. That 3 only. That 3 only. I want you to get the forces in BC, that structure, CH, that structure, and HG, that structure only. I want to get the force at that point, that particular point only. So you can cut. You cut it here. Okay, you cut it there. Because I asked you to get the forces. So you can do analysis on the left hand side of your calculation or right hand side of your calculation. We will get the same answer for forces in BC, CH, and HG. So let's begin with that one. Copy. Move to here. Paste. Okay, if you have decided to do the calculation on that side, okay, you remove all of them on the one in the right hand side. Remove it. This. Remove all of them. Remove all of them. Okay, remove all of them. Okay, remove all of them. Remove all. Remove all of them. Okay, so remember when we did 2D rigid bodies, what happened if you have when you cut the cable, you have force. Okay, so now we have force. Force in BC. Okay, force in BC. Force in CH. And also you have force in HG. Force in HG. Then you remove the things that you remove that line. How to remove that line? Okay. So you do the analysis at that point. So you do the summation of force in X is 0. Summation of force is Y that equal to 0. Summation of moment at any point is equal to 0. You're taking moment at point H, you can get FBC. And then when you have a force BC, everything soft. Okay, this is we call it as a section method. We call it what? This is section method. Or if you don't trust me, you want to do on the right hand side. How to do that? No, it's not here. Cut it here. And we move it here. Okay, if you want to do the analysis on this side, okay, so you just remove the part in your left. Remove it. Okay, so here, same thing here. You have force. Change color. That one is easy. So you have F. What force here? FBC. What force here? CH. And force HG. So same thing here, same thing here. Same thing? No. Kenapa dia padam? Same thing here, same thing here, same thing here, same thing here. You have force F BC. Okay. So you do summation of moment at point C is equal to 0. Huh? So summation force in X is equal to 0. Summation of force in Y is equal to 0. You will get the same answer. Huh? If you get positive, means is in tension. If you get negative, it is in compression. Okay, that's it. Easy. Huh? It's much easier. It's much easier. Let we begin several examples here. We try to do so. So then you now you have enough knowledge on how can this mouse doesn't work. Okay. Okay, you should remove the pen first. How can it become like this today? So you have many set of questions for you to try at home. Okay. You have many forces to try at home here. Okay. Determine the forces in member BC. Okay. BC. Okay. CH and HG. Okay. So question 3.
Sir,
Yeah.
so when we're doing the section method and we found that in the trusses there are some 0 members, so we can just ignore it. We no need to
Yes.
draw it in the free body diagram, right?
Okay, I understand very well. Better draw it, say force Hg, then put it at equal to 0. Okay, put it F, say you say FBC, say if it's 0, you draw it also. FBC is equal to 0. Better to safeguard your mark. Okay, paham Oh, this is interesting. Oh, okay, this is interesting. Okay, how do I do this? So, okay, we will do this. Okay, we will do this. We will do this. Okay, because that one is 3, that one is 2. AB, you hear one AB, BH, BH, ABH, GH, carry that here, and CF, and CF. This is interesting to do. This is interesting to do. Okay, it's so easy, this one, I think. It is some trick there. AB, BH, HG. They ask you also CF. What is CF? What is the force in CF?
0.
Good. Okay. So you just do cutting at here and CF give us 0. Then it means you understand CF is a 2 force member. This one not interesting. This one not interesting. I like this one. Okay. I like this one also. Okay. I like that one. Okay. No, we do the BC. I'm looking for that. Okay. I'm looking for this. This is the exam paper that they asked me 23 years ago. That one. Okay. Determine the force as question 7. Force in members JK, okay, JK, BJ, BJ, and BC, and AB, and AB. Okay. So what to do now is I have to redraw this one. Oh, because I cannot use software to delete the right hand side of, okay. For you, I'll draw it for you, okay? I'll draw. Can you try question 7? Can you try to do that? Question 7, while waiting me to draw that one. Okay, how to get that? Okay, question 7. Question 7, okay. Question 7. So when I do question 7 in university, I am assuming question. Okay, I am assuming that you will try at home question 1 to 6 in the at home. That is on how you learn in university. Okay, so let me do this for you. Okay, example 1. Right, we do this. Example, we do here. Well, okay, it doesn't work today. Yes. Okay, so you have structure like that. So example 1. Okay, like that. Okay, so go like this. So force it like this. This is point A. This is point J. This is point K. This is point L. This is point B. This is point C. This is point D. This is point E. Okay, so you apply force. Apply force. Apply force. Insert. Draw the red color. $10 there. 10 kilonewton. There. Two force only. So the distances all are given by that height. That height is 4 meters. That one is that one given by that one is 3 meters. And the one is by 3 meters. The angle here is 30 degrees. Angle here is also 30 degrees. Okay, you are not given the distance there to there. Okay, you are not given there. Okay, some students are already panic in the examination because no distance given there. Can you get to me? Okay, you know this one is 4, this one is 30 degrees. Can you tell me what is the distance AB? Please tell me. The distance is not given also here from B to D. Can you get that distance for me? So you know this one 4, this one 30 degrees. Can you tell me what is the distance there? Hello? So cos or tangent 30 degrees is equal to 4 over AB. They can get AB for me. Don't panic in the examination. The distance is not given and so on. AB is what?
6.9 betul.
6.9 meters. This one also should be 6.9 meters, right? Okay, don't panic in the examination. The distance is not given and so on and so on. Okay, the first thing is to do the free body diagram correctly. Copy. Go to paste here. Okay, go to paste here. And you do the erase. Small erase. You remove this. When you remove this, then you replace with the force. Okay. Remove this. Okay. Remove that. Then you have AX and AY. And FE. That's it. Okay. So this is overall free body diagram. File, home, draw, erase. This is overall free body diagram. Okay, overall free body diagram. So that one is this is okay. This is so simple for you. So resolve all the forces in X into I, J, K. So you have here component at 10 what? 10 cos. This is 10 cos what? 10 cos what? 10 cos what degree there? 10 cos 10 degree. That one is 10 sine 10 degrees. Okay,
30
summation.
30
What
degree.
degree? 30 degree. Yeah. Well, let me see. Let me see. Let me see. Oh, 30 degrees. Okay, 10. This is 30 degrees, right? 30 degrees. This is 30 degrees. So summation of summation. You do moment first. Do moment first. But normally you have to do moment first. Okay, summation of moment. Okay. Summation of moment at A is equal to 0. What do you have? 10 times 6.9. Okay, plus 10 cos 30 degrees by 12.9. Okay, minus FE multiplied by 6.9. What is the distance there? Calculate for me. 6.9 multiplied by 2 plus 6, that equal to 9.8, that equal to 0. Then you will get your FE. Tell me what FE? Then you have summation of force in X is equal to 0. You have AX plus any force, AX plus 10 sine 30 degrees equal to 0, and then you will get AX equal to what? Summation of force in Y is equal to 0. What do you have? AY minus 10 minus 10 cos 30 degrees plus FE that equal to 0. Tell me what is your AX and AY here. Do that. Okay, we do this many time. Okay, we do this many time already. Tell me your FE is what? AX is what? AY is what? Tell me. A simple moment there. We did this many times. Or you put it in the, no. Do that for me. Get the force FE from the moment. AX plus 10 sine that equal to 0. Okay. Tell me what is FH, AX, and AY. Hello? Are you working on it? Okay, FE is equal to FE is equal to 9.1 kilonewton. AX is equal to -5 kilonewton. AY is equal to 9.5 kilonewton. So Fe is equal to 9.1 kilonewton. Change color for that. Fe is equal to 9.1 kilonewton. Ax is negative 5 kilonewton. Come. Okay, I'm taking static. Okay, we have a new lecturer here. Dr. Farouk. See? Oh, handsome. Very handsome. Tapi dah kahwin. See? Bersorang. Okay. Okay, so do that for me. AY is what? AY is 9.5 kilonewton. 9.5 kilonewton. Can all of you try to do that? Make sure you get the same answer with Sharp. Fe 9.1. Okay, from what? From Zulhelmi. Fe 9.13. Ax negative 5. AY 9. I think true. Okay, I give you another few minutes. JK, the question asks you to get forces in where? Forces in where? Aduh. Forces in, if you know the forces in JK, KB, and BC. Okay, BC. Okay, can you do that? Same answer? Everybody get the same answer? The question asks you just only to get the forces in JK, BC, BK, and BC. Get to me the AX, AY first. Hello? Are you with me?
Yes, doctor.
You get the same answer, Chandran?
Yes, doctor. Same answer.
Okay, are you ready to proceed? Punita, okay? Same answer? Okay, if you get the same answer, it means good. Then what to do now is copy, paste. Then so the best things to do is erase. Because this is a section method. So apa? Tak, okay. Okay, you do the section method when you cut in the middle of that tree structure. Mana dia? You cut kat sini Sini. Okay. Cut it there. So you can do analysis on your left hand side, or you can do the analysis on your right hand side. You will get the same answer. You will get the what? You will get the same answer. You will get the same answer. You get what? The same answer. So what to do now is we try to do on your left hand side. Copy. You paste there. So if you have decided to do on your left hand side, means what? Means you have to remove all of the structures in the right hand side. Please. Remove all this. Remove all this. Remove all this. Okay, remove all this. All this, remove. Okay. Remove all those. This, remove. Remove that. Remove that. Remove it. Remove it. Okay, remove this. Okay, you have when you cut that section. Bila you potong section tu, home, draw. So you have FJ force or tension. You may put force or you may tension is same thing. Force in J what here? I can't remember. Oh, kenapa lah? Ya Allah, kenapa?
Saja rosak.
Tu?
Sama ada saja ataupun buat laptop tu rosak.
Rosak, cuba try pagi kajian ni.
Boleh tak? Macam itu.
Kalau saya datang, kelas buat kat rumah. Dia saya lupa bawa pen ni. Aduh, datang sendiri. Boleh? Can
Ya.
Try.
Tripod. Apa ni semua masuk je. Oh, kecil sangat tak boleh.
Tak boleh lah.
Tak pernah saya baik rumah lu.
Aduh,
Saya tu.
sian lah.
Tengok tak apa. Mana? Ibu rosak.
FJK, okay. FJK. Then you have FBK and FBC. So easy. You know, you have your AX is what is AY? I can't remember just now. AX is negative AY. AY is 9.5 kilonewton. AX is what? AX is negative 5 kilonewton. Don't change the direction from the original plan. So can someone tell me this angle? Can someone tell me that angle? Because you have the 4/3. Hello, can you tell me the angle there? Hello. That 4/3. Hello. Tension 4/3. What is angle there?
53.13.
Very good. 53.13. Then where is the best part to the moment? Where is the best point to the moment?
B.
The point that we have two unknown. Yes. So resolve all the problem. Summation of moment at point B equal to 0. So you have only FJK multiplied by the distance there is 4. Okay. You are sitting at point B. Okay. AX doesn't affect that. Okay. Plus AY multiplied by what? 6.9 that equal to 0. So FJK is equal to negative AY is negative AY is what? AY is 9.5 multiplied by 6.9 over 4. It is in negative, mean it is in a compression. Okay, tell me FJK is what? Tell me FJK. Tell me FJK in compression. So what to do now? What is to save it first? File. Go to save. FJK, negative what?
Negative 16.5.
16.5 kilonewton. It is mean compression. Okay, don't change any direction of the forces. Okay. So you do now summation of force in X is equal to 0. You have, this is fun subject, right? Common sense. AX plus FBK cos 53.13 plus FJK everything equal to 0. So then you can get FBC, FBK. Tell me what is your FBK equal to what? BK. So you have summation of force in Y is equal to 0. You have AY minus 10 AY minus 10 plus this is FBK. BK. What else that we don't know yet? No, this is F. B, this is BC, sorry, yeah. This is F, BC. Sorry, but F, BK, F. BC. So summation of X there is somewhere wrong there. AX, this is FBC. We missed the FBC there. FBC, FJK. Okay, so summation of force in, we do it again, AY, in AY, okay. Force AY plus minus 10 plus FBK sine. Okay, FBK sine 53.13 that equal to 0, and then you will get the FBK first. FBK, how much? FBK from here. For that particular point, medium iris in X. Sorry. So in X, AX plus FBK, okay, FBK cos 53.3, then plus plus FJK, you know already, plus FBC equal to 0, then you can get FBC from the X equation. Sorry, I missed the FBC just now. Can you get me FBC and FBK? FBK is equal to 0.59 kilonewton. FBC is equal to 21.16 kilonewton. There's nothing wrong, right? Yep. AX plus FBK cos 53.13 plus FBC. Okay. Okay. Plus FJK plus FBC equal to 0. Summation of force in Y equal to the EY minus 10 plus this. Okay. Get that to me. So from the calculation by, yeah, we have FBK is 0.59 kilonewton and FBK is 0.59 kilonewton and FBC is 21. Are you getting the same answer, Wisham? Everybody? FBC is 21. Kilonewton. Okay. Try to calculate that. If you don't practice that, you practice in the examination. Everybody get the same answer? FBK 0. FBC, okay. Okay, for Muhammad Hafiz get the same thing. Unita also get the same thing. Tell me. Hello, are you getting the same answer? I think yes, okay. Good. Okay, that's it. Okay. Let me revise again. This is the fun and enjoyable part of the analysis. Actually, this is static, where the static began with. Okay. You are okay. Very brilliant to do mathematics. Okay, to get mark. Then don't forget the free body diagram, this and that. If the example says this, get the force in JK, BK, and BC. Then draw the free body diagram correctly. Free body diagram. You remove the pin, and then you have the force. Okay, you remove the pin, then you have the force. You remove the pin, then you have the force. And then get the external forces AX, AY, and FE simply. And then you cut it into 2 sections. You can cut 3 structures, Punita, 3 structures, Farha, 3 structures only. 3 structures only. Then it's up to you to do analysis on left-hand side or right-hand side. The easiest way to look the simplest part. And if the simplest part where you have less forces in left-hand side, you do the analysis on left-hand side. Okay, if you have more forces, less forces in right-hand side, you do the analysis at right-hand side. If you if you want to do the analysis on the left-hand side, remove all the forces and the structures on the right-hand side. That's it. This is fun. I want you to get full mark for this. Then I will ask you to do maybe over the weekend to do the assignment on this. File, we go to save. Okay, that's end of our meeting today. So we finish with trusses basically. We'll do frame and machine next week. The frame and machines next week. That's very important materials, not for you only for your examination, also for knowledge for you to do next subjects for mechanical. Okay, if you are good in analysis of structure, it means that you are solid mechanic 1, solid mechanic 2, dynamics, and so on. It's so easy next semester. Okay, it's going to be very easy for you next semester. So maybe I will do class Sunday from 9. Okay, from 9 to. Okay, I will decide later on. Okay. That's the end of our meeting today. Bye bye. Thank you very much. Okay. Bye bye.
Thank you, doctor.
Doctor. Thank you, doctor.
Thank you, doctor. Bye-bye.
Bye-bye, doctor.
Bye bye. Bye bye. Bye bye.
Thank you, doctor.
Thank you, doctor.